Hey everyone, in this video I'm going to talk about dot product. I know in the last video I said we'll talk about matrix multiplication, but before we do that, for those of you who already know what dot product is, you can skip this video, but um, it's pretty important to know what dot product is and what basically the operation of it is um, in order to really know how to multiply matrices. So basically, I mean, let's just say you have some point, in two dimensions. Let's say you have point A. Whoa, that's really dark. Let's say you have some point A. We'll call it 1. Actually, I'm just going to call it x1. And then I'm going to call some other point x2. And then let's say I have some another point B. And then I'm going to call it y1 and y2. Now, dot product, it's symbolized by a little dot in the middle, kind of like multiplication. So when you have 2 times 3, right, what do? You do 2 times 3, which is just 6. But what about if I say, what is A times B? Well, I can't really multiply this, right? But what I can do is that this is called dot product now, which is A dot B. And what basically this means is I'm going to have one number, one scalar, which will be my answer. And how I find that is I take the corresponding first values, which will be x1 and y1. I multiply them together. So x1 times y1. Then I'm going to add them to the corresponding y values. So x2 and y2. The product of x2 and y2. Now, you can quickly realize that I cannot do dot product with something like if A was 1, 2, and 3, and B was 2 and 3. Cannot do dot products because the 3 over here will be left by itself. But for a quick example, let's say I have, and normally these will be vectors, so you normally see like a little arrow on top, or if it's printed, then you'll probably see like a bolded out A instead of just like a normal, normal bolded A. You'll see like A, and A will be bolded or B will be bolded. But let's ignore all of the formal kind of things for now. It's just important that you get the idea how to find a dot product. Now, let's say for an example, let me change colors. So example, let's say A vector is equal to 1, 2, and 3, and B is equal to 5, 6, 7. Okay, now what would be A dot B? A dot B. Well, we'll kind of follow the same formula over here, but instead of 2 coordinates, we have 3. So it'll be 1 times 5. So 1 times 5 is just 5, plus 2 times 6, which is 12, plus 3 times 7, which is 21. So what is 21 plus 12? That is, I can't even add right now. So okay, this is 17, 5 plus 12, and then so 17, we have 8 and 3. Alright, so 38. So A dot B is equal to 38. And that's the answer. It's as simple as that. Okay, you can only do the dot product if you have the same, if you're in the same dimensions, basically. I have 3 dimensions over here and 3 dimensions over here, and then basically what I'll do is I'll take the corresponding coordinates, multiply them together, and then in the end I'll just add them up together. Another quick example, if you still haven't gotten the hang of it, is let's say B is equal to 2, 3, negative 1, 8. And C is equal to 0, 1, 5, and negative 6. Okay, I mean, I might mess up in like adding them together in the end, but we'll see. So what is b dot c? Well, first of all, can I do b dot c? Yeah. Why? Because there's 4 elements on the b vector, and then there's 4 elements on the c vector. So yeah, I can do that. How would I do that? Well, 2 times 0, that's just 0, plus, what is 3 times 1? 3, plus negative 1 times 5, that's negative 5. And then lastly, what is 8 times 6? So 48. Or sorry, 8 times negative 6, so it'll be negative 48. Negative 48. Right? So what is this? 0 plus 3, that's 3. 3 minus 5, that's negative 2. Negative 2 plus negative 48. Now be careful with the minuses and the pluses, right? So negative 2 minus 48 will be negative 50. So I think I'm running out of space right here. So b dot c is equal to negative 50. Okay, so now that you know how to do dot product, you can easily do matrix multiplication, which we will go over in the next video. Good luck. See you in the next one.